Hopefully this records faster. Okay, it says we're recording. Great. Okay, so the first thing that I would normally do is I would say, do you have any questions from yesterday?
I have a question.
Okay, go ahead.
It's about the homework. So I saw that you did post the chapter 10 homework and that it's connected to the book now.
Yay! Right after class that came up and I was like, oh, okay. Anyway, yes.
Yeah, so I already, I was just wondering, like, are we going to be doing like a chapter like a new chapter every day, or is it going to be like every couple days, or how exactly does that?
Yeah, it's pretty much going to be a chapter a day. Plan that should be the basic plan, is we're going to go real fast. So I did assign chapter 10, but since I didn't assign it in time for class yesterday, normally chapter 10 would be due today. You would have had a quiz today, but I figured since you took all those quizzes for city training, then that was good enough. So I am going to have chapter 10 quiz due on Monday as well. I think we're going to do chapters 8 and perhaps 9. We'll see how far we get today. But I think a minimum of chapter 8 and perhaps 9 if we get that through it. So, and so we'll have a quiz at a minimum on chapters 8 and 10, maybe 8, 9, and 10. We'll kind of see how things go. Okay. And then the homework for all 3 of those will be due on Monday as well. And we'll have a quiz that will be due right before class. So
right before class, so like it'll be available like the night before, or only like in the morning? Because that's like 6:30 for me.
So yeah, so I'm going to, when class gets over today, whatever we covered today, I'm going to write a quiz based on whatever we cover today. So I know we'll cover at least chapter 8, maybe chapter 9, because I think those are 2 short chapters. It's funny to me because in the old version of this book, chapters 8 and 9 were like chapter 1 and 2. I don't know why they moved on. Chapter 10 was like, it was a later chapter, but like I said, I think I said yesterday, I usually make you guys do a project, and usually you need to have the city training before you start the project, and so I usually make it the first day of class, because I always think it's a little interesting and people are like, oh, this isn't quite so mathy. It's kind of interesting. So we'll get mathy, trust me. So in fact, I probably should have given you an overview. The first, I don't know if we're going to have 3 or 4 tests, but usually the first 2 tests are pretty easy. And then the 3rd / the 4th tests are really hard, especially test 4, because that's when we're going to get into hypothesis testing, and it's hard. So yeah, typically, just so you know, usually my first test is around a B average, which is pretty good, and my last test is usually around a D average, just because it's really hard. So just, you're forewarned. Not trying to scare anybody, but be forewarned. It's hard. So it's hard for everybody. It was hard when I learned it. So any other questions?
I have a question. If I understand that some courses are allowed a pass-fail grade instead of a letter grade.
Okay.
True?
Yeah, I mean, that's true every semester. I know last semester with the coronavirus, they kind of changed. They allowed a later date for credit, no credit. I'd have to look and see what the date is on that. But yeah, you can certainly do that today if you want to change it to credit, no credit. I'm positive you can do it still today. I think you can make any changes probably for about a week, and then kind of no harm, no foul. So
I'm not sure if that would be in my best interest. I would have to talk to the people at the program that I wanted to get into, and see if that would be okay.
Yeah, it all depends on the program you're trying to get into, how things work there. So sometimes they require grades, and sometimes Just getting a, oh, that's weird. I'm trying to, Elise, if you watch this later, Elise, I don't know why this is working, but I will tell you, if you download the team software and if you use your UVU login, you don't need to have me admit you. And I know Elise is trying to join, and I feel bad that I've clicked on admit, and then it says it failed, so I don't know what's going on there. So, but anyway, yeah, the team software's good, and then I don't have to worry about it. In fact, Wes was here before me even today, so. All right, Elise, I think you made it. Welcome.
Thank you.
I know you've been having troubles, and I keep trying to admit you, and it wouldn't let me, but it finally let you in, so yay.
Thank you so much.
So I will tell you this, even though you probably didn't hear what I just said. If you download the team software, it's free software. And if you use your UVU ID to log in,
Okay.
then I don't need to admit you to class. You can just come.
Okay.
So that might be you're probably, are you using the web interface?
Yes.
Yeah, okay, that's probably why. So, all right, any other questions?
I had one quick one. You were talking about how your first test was around a B average and your last test was around a D. Do you grade on a curve at all?
No.
Okay.
Well, yeah, no, I don't. So, I will tell you this. I think I put that in the syllabus again. I do allow people to substitute their lowest test score, which is usually test number 4, for their quiz average. Now, normally in class, I know college students don't always like to come. I think it's more critical than ever during this online environment that you come to class. And so that's why, for the first time ever, I'm requiring attendance, and that's 5% of your grade. So it's not a lot, but normally I give the quizzes in class instead of online. And so that is the incentive to come. But I've also learned from last semester that it takes me a lot longer to explain things. And so I need all of my, I can't cut out any class time for quizzes. And so that's why I have the quizzes due before class, so it allows me to have a little bit more. So I'm still probably going to do the same thing. If you're taking the quizzes every day, you can substitute your quiz average for the entire semester for your lowest test score. So that can help. Any other questions? All righty then. Well, so let's go ahead and get started. I think, I know we've had people coming and going, so I'll state this one more time, just for the record. The online book is now available. And then whatever we cover today, I'm going to have a quiz on that will be due Monday, right before class. So let's jump into chapter 8. And let me see here, share my screen. And I will post my lecture notes after class. So chapter 8 deals with some basic sampling techniques, and the field of statistics has its own vocabulary. So you're going to need to know all of these terms. I'm going to introduce a lot of new terms in chapter 8 and 9. So the first term that I want to, want to bring up is statistics. You can think of it as the science of data. It's often more art than data. How we define things affects our conclusions. So in statistics, we define, organize, collect, summarize, and analyze information to draw conclusions to answer questions. We also say how confident we are in our findings, though sometimes this gets left out, especially in like news reports. Now, I want to tell you a true story about what happened with my very first job out of college after I got my master's degree. I worked for a company up in Salt Lake, and we were studying brain injuries. And so one of the interesting things about that was we wanted to know how a person got their brain injury. Was it a football injury, car accident, boating accident, what sort of a thing. And so you would think that's a really simple question, right? Well, I got a call from one of the hospitals in Georgia, and she said, "So I'm not sure how to define how this person got an injury. Here's what happened." Okay. So the person is standing in the back of a pickup truck holding a mattress. You already know this isn't going to go good, right? So the vehicle crashed, and the person fell out of the back of the pickup truck and hit their head. So this is really where I wish that I had you guys online. So maybe I'll stop sharing my screen. So in fact, I will for a second here. So what I want to, she said, so do I consider this a fall, or do I consider this a car accident because it was involved in a vehicle? So I'm gonna put you guys in my position, and I want to see how you would answer that question.
I would assume it's a fall.
Okay, so Wes is going with a fall. What else do you guys think?
I think it'd be some sort of maybe construction accident.
Construction? Oh, it wasn't a construction. It was just somebody moving a mattress.
I would say it's a fall because even just because what was I gonna say? They could have fallen out even if there wasn't a crash. So.
Okay. Anybody else? There's no right or wrong answer, by the way.
I would say it's a fall.
Okay, so you guys are all going with false. Nobody's going with a car crash, car accident. I usually get a difference of opinion on this. Well, so I decided I have an idea. We'll go to the government and we'll see how do they classify this. And so what you'll find is the government can't agree. The National Highway Transportation Safety Administration says, well, since it involved a vehicle, it is a vehicle accident. OSHA says it's a fall because the person fell out of the truck. So what this goes to prove to you is sometimes you're going to run into these situations, and you as the study person get to decide how you want to classify that. You can classify it either as a fall, which it sounds like most of this class would do, or you can do that as a vehicle accident. And to be honest, I don't even remember. I think we called it a vehicle accident because it involved a vehicle, I believe, but I can't even remember. So I might be wrong on that. But anyway, so how you define things affects things, and so you as the decider get to decide what it is. So some other terms, bias. Okay, so the idea with bias is to systematically favor certain outcomes. Often bias is unintentional, sometimes it is not. Now, I know a lot of people think of bias as, well, I'm biased against you, or that's not what I mean when we're talking about this. So the idea with bias is you're systematically favoring certain outcomes. So one of the examples I like to give is, if you go to the mall, so sometimes the mall's open before the stores are actually open. And so if you go to the mall at, say, most stores open at 9 o'clock. If you go at 8 o'clock, who's going to be in the mall? If you want to do a survey, who's going to be there? Do you guys know? Can anybody go to the mall before it opens?
Usually store workers will just
Employees.
start like setting up everything.
So there are some store workers, but you probably can't talk to them because they're in their locked store.
Oh, right.
The homeless people sleeping outside.
Maybe. But they have the mall walkers. They're usually senior citizens that are just walking the mall because it's it's indoors and good weather indoors, and so yeah. So if you were going to do a survey, you might get all these people that are over 60 years old if you go before the mall opens. And if you go after school, who's there after school? This is kind of a stereotype. I don't know that anybody even goes to the mall anymore. Malls are closing, but it used to be back in my day, especially, that all the teenagers thought going to the mall was a great thing to do. And so the idea here is if you're doing a survey and you want to talk to people at the mall, if you go before the mall, you're going to favor old people. If you go after school, you're going to favor teenagers. And so because of different habits that people do, you may not intentionally try to skew your results, but you're going to systematically favor either old people or young people. If you go during the day, you're not going to get any business people except for the mall workers, perhaps. And so, so that's what I mean by bias. Often bias is unintentional. It's not as if you're trying to, although I guess maybe if you knew that beforehand, maybe you did want to talk to old people, or maybe you did want to talk to teenagers or whatever. But just, the time of day could systematically favor certain outcomes. Okay. All right, let's move on to the next term. The next term is called a population. So a population is the entire group of individuals we want information on. And a sample is a subset of the population. So the idea here is it's often not possible to survey the entire population. So this year's an election year. We're going to be voting in November. In November, we are basically going to survey the entire population on who they want for president and governor and things like that. But it doesn't make sense for polling companies, especially, to interview, let's just say interview everybody in the state of Utah. I mean, that would take a lot of money to do that. And so a lot of times we will use a sample, which is a subset of the population. We'll talk to generally 500 to 1,000 people. And the idea here is we will survey these people, and if we do it correctly, we will draw conclusions about who Utahns think should be the governor, for example. And so if we do it properly, a good sample, we can figure out who Utahns want for governor without having to talk to everybody. So a lot of times they don't necessarily state the population of the sample. So in your homework, you're going to have questions that will say, okay, what is the population? A lot of times you can think of the population as the intended population. So so generally, for example, if maybe your population would be U.S. residents who are 18 and over, and your sample, you're only going to talk to 1,000 or 1,500 people. Okay, now the one thing that I want to say about these two terms is, I know we're learning them on literally day 2. This chapter is the basis for the rest of the semester. So it's going to be very important for you to distinguish between what is the population versus the sample, because the equation that you're going to use is going to be different based on whether you're dealing with a population or whether you're dealing with a sample. So this is a very important foundation. So one example is the current population survey. They usually interview 60,000 households each month, and they want to estimate the opinions of 111 million samples. So usually you're not going to get a sample that's this large, but this is one of the current population survey does use a sample that's that large. Okay. All right. So now I'm going to scroll up here a little bit here. Now we're going to talk about a parameter and a statistic, and maybe a census. So the idea here is, if you wanted to interview the entire set of individuals you want information on, that is what's called a census. Now, it just happens to be this year is a census year, and the idea with a census is the U.S. government, especially this year, is trying to include the entire population in the sample, and so. So census doesn't refer to just the U.S. Census. If I wanted to do a survey, we've only got 12 people in our class, and so it theoretically shouldn't be hard for me, although I still don't think that we've got everybody here today. How many do we have? 1, 2, 3, 4, 5, 6, 7. So we've only got 7 people in our class. It should be fairly easy with a class of 12 to include the entire population in my sample, but I might have to do a sample of just 7 people, since that's all I have here today. So the idea here is with these two terms here. So a parameter is known as the true value, and it is usually unknown. So parameter applies to the population, okay? So for example, I'm going to go back to the election example because I think that's pretty easy. So in November, or maybe we'll go back to 4 years ago, here I'm going to just make up some examples here. In fact, I'm just going to make up this example. So in the 2016 election, maybe I'll do it this way. In October 2016, Gallup surveyed 1,200 Americans and found 1% favored Hillary Clinton. In the November election, it showed Americans favored, or maybe I'll write it this way, 52% of Americans favored Hillary Clinton. Okay, so I don't know if those numbers are right, but it's good enough for what I'm trying to do. We'll pretend that they're right. So based on this example here, I'd like to open it up to you. What is the population? What is the sample? What is the parameter? And what is the statistic? Okay. Now I wish I could remember who was all here, so I shouldn't do it alphabetically. Here we'll start at the bottom of the alphabet. Yami, you're lucky in that you can answer any of those 4 questions. Which one do you think you know the answer to?
I was just looking at the textbook to recollect what population would be, but I'm assuming we want information about the Americans, right? We want to know,
Okay.
would that be it?
So the
Population?
population is all
Right.
Americans, or maybe we should say all adult Americans, because
Yeah.
obviously if you're
That's who
under
can.
18, you don't count. Okay. Very good. Well done. Correct answer. What is the sample in this case? And we're going to go to Wes. What do you think the sample is?
In this case, it would be the people that they polled. So I'm sure if it was Gallup, it was likely registered voters.
Oh, so it doesn't say registered voters here. What is it? What does my example say?
It just says American. So
How large is my sample?
oh, sorry, 1,200. Sorry.
So yeah, so we'll go with the 1,200 Americans. Okay. So all adult Americans would be 111 million or whatever it is, whereas the sample would just be the 1,200 Americans. Okay. Well done. How about Seth? Can you tell me what do you think is the parameter?
Would be the 52% since it was the in November election.
52% voted for Hillary, voted for Hillary Clinton. Well done. And the statistic would be what, Mary?
Oh, sorry. The statistic, I would say, the 51%.
51%. Okay. Perfect. Well done. Okay. So now I want you to really, I think when people do this chapter, they think, oh, this is really easy. And then we go on to other things and then you forget about it. But this skill in picking out the population sample parameter and statistic is super, super important for the entire semester. So please do really well on this and then never forget it, because the whole class is based on this, especially the hard part when we get to test number 4. It requires that you know how to do this perfectly. Okay. So, and that's where people, believe it or not, mess up. Okay. So, a census, I guess, once again, you attempt to include the entire population in the sample. Sometimes samples are actually better than a census. It wouldn't be wise to test a light bulb to see how long it lasted, because then once the light bulb burns out, obviously it's no good to use anymore. So in that case, you would not want to do a census. You just want to do a sample and then you could still sell your light bulbs. Okay, so now we're going to talk about a simple random sample. And so the idea here is, hopefully, you know what, I think we're going to do a little bit of an example here. So we're going to do a sample of n individuals are chosen so that everyone has an equal chance to be chosen. So randomization in real life can actually be very difficult. One researcher used a random number generator in Excel and discovered that Excel actually didn't give you random numbers. So it would be nice to do, but it can be very costly. In order to do a simple random sample, you need what's called a sampling frame, which is a list of all individuals. So sometimes it's hard to get a list of all individuals. And so a lot of times what people will do is they'll rely on a convenience sample. These are easy to reach individuals. You know, if you're going to go to the mall, who's going to win the election or the football game? If you go in the morning, like I said, you're going to talk to older people. And then the question is that representative of the entire population you're looking for? So if you go after school, you're going to have a lot of teenagers. the question is that representative of your sample? Probably both samples probably are not. So the mall sample is going to overrepresent routines or retired people, the prosperous, and miss out on poor people. Voluntary response sample, that's another type of sample. Often done on websites and news call-in shows. People with strong feelings participate, others don't. This is one of my favorite examples, Ann Landers. Some of you are too young to even remember who Ann Landers is. She used to have an advice column and in the newspaper, and people don't even buy newspapers anymore. But anyway, Ann asked, if you had to do it over again, would you have children? 70% of her listeners responded no. And she had a big sample of 10,000. So the question is, do you think that 70% would be representative of all Americans or all newspaper readers?
Absolutely not.
Yeah. So for whatever reason, she got a lot of bitter people that didn't want to become parents anymore. So
some people that need advice from the newspaper.
Yeah. All right. So now, what I'd like to do for a moment, I'm going to post. I need to find this up here. I have let's see if I can find it. I'm going to post this as an announcement. And so here we go. This is it. So this is something that I would recommend that you all print out. It's 5 pages. These are the formulas and equations that we're going to be using this semester. And so we're not probably going to do Excel this semester. I've decided against it, but normally I would. On page 2, we have a random number table. This is something I generated myself. And so what I'd like to do is to get you guys used to, normally I would do this in person as a class. And, but what I'm going to do is, in this case, let's see, Elise is the first one. So Elise, you guys are going to be, I think here's what we're going to do. We've got 1, 2, 3, 4, 5, 6, 7 people. Wish we had 8, but that's all right. So Elise is number 1, Allie is number 2, Easton is number 3, Mary is number 4, Seth, you're number 5, Wes, you're number 6, Yami, you're number 7. Okay, so I'm going to conveniently do a sample of, say, the top 4 students. So Mary, Easton, Allie, and Elise. You're group 1, and then group 2 is going to be Seth, Wes, and Yami. So the idea here is we've got 7 people in our class. So we'll pretend that 7 people represents the entire population of this class. This is weird. I'm not used to having a class this small. Usually I at least have 10 people here. But okay, so we've created a sampling frame. I've numbered everybody from 1 to 7. Now, if we had 10 people here, or 20 people, or 40 people, as I normally have in my regular classes, 40 would be a 2-digit number. Usually what I would do is I would have everybody count off your number 1, number 2, 3, all the way through 40 or whatever. And so 40 is a 2-digit number. We only got 7 people, so we're only going to use a 1-digit number. Now, the idea here is with this random number table, so I've created my sampling frame. It goes from 1 to 7. So group number 1, Elise, Allie, Easton, and Mary, I would have you use line 1, and then group number 2, which is Seth, Wes, and Yami. Maybe I would have you use line 10. And the idea here is, here, I'm going to pick a different line. I'm going to pick line 30. Okay, so let's pretend that I said, okay, so I'm going to pick first person is number 3. Number 3 in this case would be Easton, and I would ask you my survey question, such as, and I'll just say, who do you want for president? Easton, tell me, is it Donald Trump or is it Joe Biden? Easton, if you're answering, you're on mute or something. Can you hear me, Easton? Oh, there you go.
Yeah, sorry. My internet's been kind of spotty lately.
Okay. So you would say who you want for president is?
Is it this year?
Yeah.
Probably Trump.
We're doing Trump. Okay. All right. So I would go to the next person, which would be group number 7. Person number 7, Yami. Who do you want?
Yes.
This is
Joe Biden or Donald Trump?
But I think I would go Trump.
Trump. Okay. So then we would go to number 8. 8 doesn't exist, so we'll skip that number. 3, well, we've already picked on, that was Easton, right? So we're not going to pick on him again. So then we would go to 6, which is Wes. So Wes, who would you pick?
Donald Trump.
Okay. All right. So that would be a sample of 3 people. So the idea here is you're just going to go through this line. Now, if I were using 2-digit numbers, the first 2 numbers I would use. So 37, I would ask number 37, who do you want? And then 83, well, 83 doesn't exist, so we'll skip that. 62, skip that. 64, skip that. 93, skip. Wow, these are big numbers. 59, 36. Then I would go to person number 36 and I would say, okay, who do you want? And so anyway, that's the idea with how you guys would do a random number table. So does that make sense, how you would use a random number table? I believe in the back of your book, in fact, maybe I should just share this really quickly, so Macmillan Learning, well, probably the easier way for you guys to access it is, let's go to assignments. So this is your chapter 10 homework assignment. Let me go back to here. So you can, just as a reminder, you can click on this thing here for your textbook, and I believe, okay, why did that go to chapter 8? That's kind of weird. Over here, I think you've got your table of contents. You can go to, okay, the tables. So random digits is table B. These will be different than the tables that I'm going to give you. So they've got them labeled this way. So same sort of a thing. If you were going to ask, you know, line 109, you'd pick number 3, and then you'd pick number 6, and then you'd pick number 0. Sometimes instead of going 1 to 7, people go 0 to 6. That works as well. And so anyway, so there's your random number table. So you'll have some questions that will ask you how to do this. I made my random number table a little differently. So the one thing that I do want to mention here, what I would do if I were you all, normally I would pass these out in class because I would say these are all the formulas and tables you need. You'll also have a standard normal table here. You'll have a t-distribution table. We're going to learn that later this semester. And you'll have a chi-square distribution table. So these are the tables that you're going to have. If I were you, I will allow you to use this on all quizzes and tests. So go ahead and print this out. You're welcome to use these on quizzes and tests. I'm not going to make you memorize all of these formulas, although some of them you will use so often you will probably kind of memorize them anyway. So go ahead and print this out. This is what we'll use for your tests and quizzes. And there's a random number. Now this clearly my random number table is different than the book's random number table. So the book's going to say use this table, and I'm just going to say use my table on the tests and quizzes. So when we're doing this, okay. So where was I? Let's go back to here. Okay. Now convenient sample. I think we mentioned that earlier. Those are easy to reach individuals. Voluntary response sample, we talked about that. Okay, so a stratified sample. Now, a lot of times when we're doing a random sample, we're going to miss certain segments of the population. And so a lot of times when we're doing a stratified sample, what we'll do is we'll randomly pick people that are maybe Black or poor, or we're going to make sure that we have a representative number of men and women or homeless. And so typically a stratified sample, if you're doing just a regular simple random sample, you might miss out on Black people or poor people or rich people or whatever. And so the idea, part of the reason when you're doing a survey, if you've ever been asked to do a survey, they'll ask you how old you are, they usually ask you your income, and they'll usually ask you your gender. And so the idea here, most of the time, although there are times when this doesn't happen, is with a stratified sample, we want to make sure that we have equal numbers of men and women, because sometimes with a random sample, you may just end up with more men than women or vice versa. And so the idea with a stratified sample is you divide your group up into distinct groups called strata, and then you take a simple random sample, SRS stands for simple random sample, within each strata, and it ensures that all groups are representative. And so if I were doing a random sample, now we've got, let's see here, so Wes and Seth and Easton are the men, and then Elise, Allie, Mary, and Yami are the women. So that's almost half and half. In fact, I'm trying to remember, in my first sample, I asked Easton, and I asked Yami, and I asked Seth. So 2/3 of the people that I asked were men, and 1/3 of the people I asked were women. So that's not representative of my population, which is almost 50-50 men and women in the class. Now, obviously, you're going to ask more than 3 people. I was just doing that for an example, but the idea here is I would probably want to get that closer to the population. Now, if I had a population of 7, it doesn't even make sense to do a sample because I've got 7. You might as well just do a census and talk to everybody, and then you'll know who are people's opinions on the election, let's say. So in our case, it would make more sense to do a census than a sample. But the idea here is you're going to divide your sampling frame into groups such as men and women, or maybe we could do it upperclassmen versus lowerclassmen, or maybe we could do it, well, I'd have to ask you your income to find out if you were rich or poor or whatever. And then within each strata, you would ask. So if I wanted to do a simple random sample, once again, it's a little silly to be doing this, but maybe I would randomly pick out of Easton, Wes, and Seth, I would randomly pick one of those 3. And then out of Elise, Allie, Mary, and Yami, I would pick one out of those 4. And that would give me a sample size of 2, which is kind of silly. But then men and women would be equally represented in that case. So in that case, I would be stratifying by gender. You can stratify on anything that you want. A lot of times, like if you're doing a real survey, you'll want to make sure maybe your racial breakup is matches the United States. So now there are cases where you might do a stratified sample that is not representative. So one example would be you have a large university that has 30,000 students. You've got 3,000 graduate students, and you want to do a simple random sample of 500 students. So if you did that, a simple random sample, you would pick 1 out of every 60 students. Now, one thing that you would do if you had a simple random sample of 500 students, you would expect, so 3,000 divided by 30,000, you could see that there are 10% of students are graduate students, which would mean that 90% of students would be undergraduate students. So you would expect if you did a plain simple random sample of 500 students, 50 of those students would be graduate students because they make up 10% of your population. So the problem is a sample size of 50 is generally too small. And so if you wanted to be able to drill down and let's say you wanted to find out opinions of students on, maybe your question would be, are you willing to pay more tuition in order to have more parking spots, let's say. And so what you could do is you could say, well, I don't want to have only 50 graduate students in my response because that's too, maybe you want to compare are graduate students different than undergraduate students. So maybe you would say, well, you know what, I'm going to have a sample of 200 graduate students and I'm going to have a sample of 300 undergraduate students. And so you can see that you're basically oversampling out of the graduate students. You'd be talking to 1 out of 15 graduate students, but you'd only still be talking to 1 out of 90 undergraduate students. So one of the ways that you can calculate your margin of error is 1 over the square root of n. And so in this case, if you had 200 graduate students, you'd have a margin of error of 7%. And if you did 300 undergraduate students, you would have a margin of error of 5.8%. And so that would allow you to better compare the graduate students' opinions versus the undergraduate students. Does that make sense? Does anybody have any questions? I should always say, if you have questions, please interrupt me so that I can answer any of those.
I have a question.
Okay.
Generally, would you want to try and have the same like margin of error if you had 2 different sampling, like groups, like amounts of people to sample?
I mean, yeah, it would depend. So some things to think about is generally when you're doing sampling, it costs money. And so some of the things that you would say is, oh, if I've only got 500 students, yeah, I guess maybe you could say, well, we'll make this 250, we'll make this 250. That would be one way to make your margin of error the same. But it might be harder to get that. And so, yeah, generally you should try to do that. Sometimes that's not always possible. And especially if you're doing a survey, let's say an election survey, you may not want to oversample a smaller group.
Yeah, like of business students as opposed to liberal arts students, because there you're going to get very different answers.
Right, right. So yeah, sometimes you just make the best do with what you can and what your budget allows. So, but yeah, certainly you could do that. Just make them both 250 and 250. All right. Any other questions? Okay, so systematic sample, one way to do this, as I mentioned earlier, in fact, maybe I should go back to my simple random sample for a minute. We had a professor come when I was at the University of Utah, and he talked about how to find a truly random sample. And in his case, one of the things that he was studying was he wanted to find out how much lead was in a tuna fish can, because what happens is tuna fish eat other fish. So if they eat a fish that's been exposed to lead, then that lead goes to the tuna, and then the fisherman goes and catches the tuna, and then they put the meat in the can, and so you're going to get lead in your tuna fish can, which is unfortunate. And so one of the things they wanted to do, just to show you how randomization can be really difficult, is with a tuna fish can especially, he wanted to figure out how to randomly select tuna fish cans. Okay, so he was from Washington State, and so he said, so here's what we wanted to do was we wanted to randomly pick cities. So maybe I should pick Utah. We'll pretend that we want to do this in Utah instead. So you'd have to have a list of all cities. So Salt Lake, Provo, Ogden, La Verkin, St. George, Neola. I'm just trying to think of weird cities. Roy, Clearfield, Orem, Spanish Fork. So there's a lot of cities clearly in Utah. So you'd get a list of cities, and then you'd have to randomly pick those cities. And you probably wouldn't want to leave out Salt Lake City since it's the biggest city. So with a true randomization, there's a chance that Salt Lake City would not get picked. But so maybe you'd want to put that one in your sample anyway. So the idea here is you list all, and I will just say that there's 200 cities in Utah. I don't know. So you'd number your cities 1 to 200, and then you randomly pick a city. Okay, so now the next question is, where can you buy a can of tuna fish? Well, you can buy it at Smith's, Walmart, Target, Albertsons, Skaggs Alpha Beta, whatever. You'd list all of the possible stores that you can do. So maybe you'd randomly pick Clearfield, and then you'd have to say, okay, where can I buy a can of tuna fish? And so you'd list all the stores, and so then you'd randomly pick, okay, Smith's Food King is your random store. Well, so then what are the brands of tuna fish that you can get? You can get Chicken of the Sea, you can get the store brand, you can get Starkist, you can get, whatever. There's a bunch of, it's probably 7 different brands of tuna fish out there. Okay, so you randomly pick Clearfield, Utah at the Smith's Food King, and then you randomly pick Starkist or Chicken of the Sea. We'll say Chicken of the Sea. Okay, so now you've got Chicken of the Sea. Now you can buy tuna fish in either oil or water. Wonder if that had anything to do with it. So now you'd have to be like, okay, now we need to randomize. Is it oil or is it water? Okay, so maybe you'll randomly pick water. And so you've got Clearfield, Smith's Food King, Chicken of the Sea in water, and then there's a bunch of cans there. And so let's say that there's 50 cans on the shelf. So you'd use a random number generator and you would pick can number 23. And so you can count over to can number 23, and then that would be the can that you would pick. And so So as you can see, in order to do this, it gets really crazy really fast on how to do randomization. And so one of the one kind of a pseudo randomization is what you would call a systematic sample. So maybe you would select every, and I put here kth individual, every third individual, every fifth individual, or whatever the number is. The nice thing about a systematic sample is it doesn't require a list or a sampling frame for each individual. A lot of times when I ask students to do a project, they'll just pick every fourth person that walks down the hall and ask them whatever the question is. And so the idea here is a systematic sample is kind of an easy randomization method, but it's not random, but it's a lot easier to do than a truly random sample. And so that's what we would call a systematic sample. We also have what's called a cluster sample. And so the idea with a cluster sample, and I will tell you this, a lot of people mix up stratified sample with cluster sample. So let me review stratified once again. So the idea here is you're going to break your group up break up your population into groups, such as maybe freshman, sophomore, junior, senior. Let's do that. You're going to make sure that so once you've got people divided up into freshman, sophomore, junior, senior, you're going to take a simple random sample within the freshmen and within the sophomores and within the juniors and within the seniors. And so you're still using randomization, but you're dividing it up into groups first before you do your randomization. With a cluster sample, you're going to talk to every single individual within a random selection. So let's say, for example, a school administrator wanted to learn the characteristics of students in their online class. Rather than obtaining a simple random sample of students in online classes, he would treat each class as a cluster. And then he would then he would talk to all of the students in that cluster. And so a lot of times, especially when I'm doing an online survey, is let's say you have an English class, there are 40 English classes, maybe you'll randomly pick 3 English classes and you'll go to those classes and you'll say, okay, I want to talk to every single student in this class. Will you answer my survey question? And so with the cluster, you're only talking to a subset within the group. With the cluster, you're talking to everybody, all the students within the cluster. Another example would be a sociologist would gather data on household income in Boston. They would break up into city blocks, and then they would randomly select the blocks and ask everybody on that block what their opinion would be, let's say. All right, I don't know why I put this in here twice. You could convenient sample, voluntary response. We did that one already. Multistage sampling would be a combination of methods. We're probably not going to talk about that too much in the class. Sample size. Obviously, you always want to get the largest possible sample as you can. That will help you reduce bias. However, it always has to be balanced against costs. Okay. All right. So normally at this point, when I'm doing a lecture in class, I would actually have us do these in class, where we would do a sample by rows, cluster sample, and that sort of a thing. But I think I'm done there. So let me just ask a question. I'm trying to decide if I just start on chapter 9 or not. Do you guys have any questions on any of these concepts we've studied in chapter 8?
Can you go back and show the math on the margin of error again?
Oh, you know what? That's a terrible example, and we're going to actually come up with a new margin of error. I'm just kind of using that as an example.
Okay.
So I wouldn't dwell on that. This is just a quick and easy, quick and dirty kind of thing, where you're just taking 1 over the square root of 200 and 1 over the square root of 300. So 1 over the square root of 200 would be 7%. 1 over the square root of 300 would be 5.8%.
Okay, so in that case is the sample size.
Is your sample size.
Okay.
Yeah. But that's actually a terrible formula, and we'll never use it in this class. So you won't even need to use it. In fact, you'll probably notice we haven't even done any math yet in this class. Basically, I gave you all the city training and that sort of a thing. So any other questions?
I have a question. Can you hear me?
Yeah, go ahead.
Okay. Is this note what is this under in Canvas? Is it under notes or?
Oh, I haven't posted it yet.
Oh, you haven't posted it. Okay.
But I will post it. In fact, I'll take out the stuff that I put in there twice. I'm trying to decide if I should start on chapter 9. I don't think I will. But just to let you guys know, where's my stuff here? If you go to assignments, I did post yesterday's notes. I think I'm going to have to delete all these homework assignments which would probably be good. Because all the dates are wrong anyway. So city training, you've done most of that. The lecture notes is under worksheets from class. If you click on that, there's no due date on this, but here's our lecture notes from yesterday. I will post today's chapter 8 as well. Just under here. So you'll see chapter 8 underneath chapter 10. So any other questions you guys have?
I have a question. It's not about the lecture or anything, but
Okay.
so the class we registered into is Monday, Wednesday, Friday, so that's why I was late. So are we going to meet on Thursdays now?
I thought we were meeting Monday through Thursday.
I'm pretty sure it's Monday, Wednesday, Friday, which is no big deal if we meet on Thursdays. I just wanted to know so I won't be late again.
Really? Are you sure? Oh, that would scare me because I've been teaching summer semester, and I swear when I looked this up, now you're making me look here because
Yeah, we're
I'm scared if I had
Wednesday.
class when we weren't supposed to have class. Because normally summer semester is always Monday through Thursday. I'm teaching trig second block, and it was weird because I swear I checked this and this was going to be Monday through Thursday, and then my other one was Monday, Wednesday, Friday. But I feel bad if we had class on a day we weren't supposed to have it, but that's what I understood. I can't talk and type at the same time. I hate this.
Just from the schedule that I like, our little registered schedule on my UVU, it says Monday, Wednesday, Friday. So.
Yeah, you're not alone. I also thought that that's what it was.
Okay, great.
Really?
Yeah.
Oh, I feel terrible because I swear when I checked this, it said Monday through Thursday. And I don't know why they changed it this semester. I'm going to have to redo my whole schedule. But I swear.
And actually,
Well,
I'm
I will get
different
it right
time.
then if this is true. Say it again.
Yeah, It's saying it's from 8 a.m. to 9:50, Monday, Wednesday, Friday. So it's different timing as well.
Wait, am I on the right thing here? Math 1060. See that this is my other, wait, this is 1060. See, that says Monday through Thursday, and then this one, it is Monday, Wednesday, Friday. Oh, I totally got those backwards. Well, I was looking at this. Well, I appreciate you telling me that. I did not realize this was a Monday, Wednesday, Friday class. I don't know why they're doing that this semester, because normally, this is what they do: 8 to 9:25 Monday through Thursday.
Rick, today just makes up for letting us out a half an hour early yesterday.
Yeah, I guess. Well, if that's the case, I will switch my schedule to Monday, Wednesday, Friday. I didn't realize that. I got my two classes mixed up. So let me ask you this. Thank you for bringing that to my attention, because I don't know why they're doing this, because this is the first time they've ever done it. But that does make me want to finish chapter 9 today. How about this? How would you guys feel? So we'll move that to next week. We'll go Monday, Wednesday, Friday next week, and then but for today, since we're supposed to meet for another hour, we can cover chapter 9. And so I will cover chapter 9 today, and then we won't meet tomorrow. How's that? Any complaints about that?
That sounds great.
Okay. All right. Well, next week, that's funny. I apparently, I don't know why they have block 2 before block 1. Is that okay? Say it again.
Does that mean we won't be meeting this Thursday either? We'll just meet today, won't have class tomorrow, and then we'll have class
Yeah,
again.
today will be the last Thursday we meet.
Oh, so we are meeting on Thursday this week.
So yeah, obviously today's Thursday, so we're meeting, but well, thank you for bringing that to my attention. I totally mixed up my classes. So all right, well, I have plenty, because I was like, I'm gonna run out of time. I've only got 15 minutes left. I don't want to start a new chapter. But if we're meeting for 2 hours Monday, Wednesday, Friday, then I do have time to cover chapter 9. Okay, so wow, that makes for a long class. Okay, so tell you what, we will, I appreciate you bringing that up. Okay, so we'll post this, so we will cover chapter 9 as well, and then I'm gonna have to totally adjust my schedule. Normally, I don't think we'll cover 2, because I don't know, I've never taught this as a Monday, Wednesday, Friday during the summer before. This is weird, so this is gonna be interesting. All right, well, let me just say this. Chapters 8, 9, and 10 are really strong on like vocabulary. And so on Monday, we'll go back to our Monday, Wednesday, Friday schedule. All right. Chapter 9 is really good because it kind of piggybacks on chapter 8 anyway. We're going to talk about observational studies. So the idea with an observational study is we're going to observe and measure, but we don't attempt to influence, okay? So sometimes this is the only way to conduct studies due to ethical reasons. So that's one type of study, is an observational study. An experiment is to deliberately impose some sort of a treatment on individuals in order to observe their response. So, there was a Danish study that tracked 420,000 cell phone users between 1982 and 1995. They compared the rate of brain tumors in people without cell phones to people with cell phones and found out there was no difference in the groups. I hate that I have my answer here Because normally I would say, is this an observational study or an experiment? And obviously you can see my answer there if this were in class. This is an observational study because we aren't imposing a treatment. People are choosing to have a cell phone versus not have a cell phone. And so this would be an example of an observational study. Now this one I can ask you guys. Researchers want to know if a certain drug cures the common cold. They divide the subjects into two groups. Half of them are given a new drug, half of them are given a placebo or a fake pill. The results are who recovers from the cold. So would this be an observational study or an experiment? Since I have the answer on the next page, I will throw this out here. And let's pick on, is it Janae? Is that how you say it?
It's Janie.
Janie, okay.
Yeah.
Janie, thank you. So would that be an observational study or an experiment?
I want to say an experiment because they're testing two different drugs or like fake pill and
Yes.
drug.
So we are imposing a treatment. And so, yeah, you either get the drug or the fake pill.
Mm-hmm.
So that's exactly right. Okay. Now, are you the one, Janie, that said class was Monday, Wednesday, Friday?
Yeah, that was me.
Oh, well, thank you.
You're welcome.
I'll give you bonus points for pointing out the error of my ways there. All right. All right. So, okay. So experiments are often preferred by scientists because they suffer less from lurking variables and confounding. In fact, okay, so and I didn't really explain what a lurking variable or a confounding was. And I do have a list. These are long. In fact, I just listened to another podcast today or a couple days ago that I kind of want to add to this. So the idea with an experiments are usually preferred because they don't suffer from lurking variables and confounding. And I'll explain what those are in just a minute. So sometimes experiments aren't representative of real world studies like observational studies are, and are done on dream patients, making the results biased. So experiments can't always be done for ethical reasons. So one of the examples I usually like to give is in my class. So pretend you're all in a regular class and we're standing here and I'd say, okay, so we want to find out if smoking causes cancer. Let's pretend we don't know that. And so what I could do is I could split the class in half down the middle. People on the right side of the room would have to smoke for 30 years. People on the left side of the room could not smoke for 30 years. Let's come back and let's see who gets lung cancer. Unless you're a smoker, you probably wouldn't like to be forced to smoke. And if you are a smoker, you would probably not like being forced to not smoke. And so it would be very hard to do a smoking study because I can't force you to smoke or to not smoke. And so usually, and smoking is a perfect example, all of the studies we did with smoking were observational studies. And I guess at this point, I should probably start telling you what confounding and lurking variables are. So observational studies are often used because you can't always do experiments for ethical reasons. You can't force people to smoke, or you can't force people to go to church. So there's some fantastic podcasts on Freakonomics. Freakonomics is one of my favorite podcasts that talks about statistics all the time. There's also a podcast called The Hidden Brain. In fact, I just heard a podcast this week. I might add one more to this that talks about placebos. And then my favorite one is 538.com. There's a website called 538.com. It's a politics podcast, and they're always talking about public opinion polling, and especially politics. Now, the thing that I love about 538.com, it was founded by a guy named Nate Silver. Nate Silver used to work for the New York Times. He's a really amazing statistician. And in the, let me think about this for a minute. In the 2008 election, I think it was 2008, there are 538 electoral college votes. And he, correct, maybe it was 2012. I think it was 2012. In 2012, he correctly, that was when Mitt Romney was going against Barack Obama. And he correctly predicted the number of electoral college votes that would go to both Barack Obama and Mitt Romney. And so that was kind of his claim to fame. Now, when he repeated it in 2016 between Hillary Clinton and Donald Trump, he was correct in predicting that Hillary Clinton would win the popular vote, but he was off on 4 states with the electoral college vote, and he predicted Hillary would win the electoral college when in fact Donald Trump won. So anyway, it's really, if you really want to get into especially political polling, they don't do just politics, they do sports and other things. But that's where the name 538 comes from, is because they're, in 2012 he got it perfectly right, but in 2016 he didn't. So just it goes to show you that there's always a margin of error. So experiments are generally considered to be better than observational studies. And then there are some really interesting Freakonomics episodes that talk about medical studies and that show that experiments do not, experiments have problems as well. They're not perfect. So another example of a good experiment, a group of rats is divided into 3 groups. The first group received analog cell phone radiation 4 hours per day, 5 days a week for 2 years. The second group received digital cell phone radiation for the same period of time, and then the last group received no radiation. And so they compared the cancer rates, and no link was found. You may have heard, it's probably not in the news as much as it used to be, that some people think that cell phones cause brain cancer. And so this was an example of a cancer study. They found there was actually no link. All right. Now, we've talked a little bit about confounding and lurking variables. These 2 concepts are really related. Confounding is what happens when the effect of 2 or more variables are not separated, and a lurking variable was not considered in the original study. So one of the definitions of lurking variable that I like to say is what you forgot to include in your study. So there was a study done that said people who eat a lot of sugar get heart disease. And then there were other studies that said sugar has nothing to do with heart disease. This was done back in the 60s. And so you've got some confounding going on. Another thing I like to say is conflicting results. So in the original study that was done that said sugar caused heart disease, the original researchers didn't ask whether a person smoked. And it turns out that so smoking became your lurking variable. And so what happened was it turns out that smokers consume more sugar than non-smokers, which is really kind of a surprising thing. So, back in the 1960s especially, Starbucks didn't exist. And so what would happen is smokers also, probably wouldn't be too surprising, they can't taste as well. And so a lot of times what would happen is a smoker would sit down with a cup of coffee. Because they couldn't taste the sugar, they would dump a lot more sugar in their coffee than non-smokers. And so it turns out that smokers consumed a lot of sugar in their coffee. And so when you take smoking into consideration, the effects of sugar vanished in the heart disease. And so smoking was the real cause of the heart disease, but because the original researchers didn't keep track of whether people were smokers or not, smoking became the lurking variable. And so confounding occurred in that you couldn't distinguish whether a person was a big sugar eater versus a big smoker because they didn't include smoking as the lurking variable. And so that can be one of the big problems with observational studies. A lot of times so in this case, you probably wouldn't automatically think, oh, I'm a smoker, so therefore I would eat more sugar, or I would, in this case, drink more sugar. And so one of the, we've talked a little bit about experiments. One of the problems with experiments is they're not always good, but with the observational studies, a lot of times if you're doing an observational study, you're not going to keep track of all the differences. There could be reasons why smokers consume more sugar, for example, than not smokers that might not make sense until you think about it later. Okay, so that's lurking and confounding. Confounding can happen on both experiments and observational studies, but it's generally recognized that confounding occurs a lot more on observational studies, whereas experiments, generally the experimenter can control those variables. All right, so let's talk about observational study types. You have a cross-sectional study. So cross-sectional study, this is an observational study where you're going to collect information over a short period of time. So maybe you'll say, okay, we want to find the incidence of lung cancer between smokers and non-smokers. We're going to, let's say we're going to gather and get all of our, we're going to collect our data over a week or over a month. And so let's say, for example, I wanted to find out if you had lung cancer in my class, and I wanted to compare people who had cancer. Hopefully, when I did my survey, nobody would have cancer, but it could happen. But the problem is because you're collecting information over a short period of time, say a month, maybe when you're doing your survey, somebody says, no, I don't have lung cancer. Then you're done collecting your data, and then the next day the person goes to the doctor and finds out, oh yes, you do have lung cancer. And so one of the nice things about cross-sectional studies, they can be relatively inexpensive because you're collecting information over a short period of time, but you're going to miss cancers that occur after the study. So maybe the person really did have cancer, they just didn't know it. So it's kind of quick and easy to collect the data, but you may miss things because it's so quick and easy to collect the data. Another type of observational study type is what we call a case control study. And these studies are retrospective, and retrospective means you're going to look back in time to see different characteristics. So the idea is this is often done in rare cancer studies. And so the idea is you're going to compare the cases, the people that have cancer versus the control and the people who don't have cancer. And so you're going to look back and you're going to look for differences between the cancer's patients and the control patients. So the idea is you're going to match people based on certain characteristics, such as age, income, whether they're smokers, etc. and try to figure out what are the differences between these two groups. So the drawback is because it's retrospective, sometimes people have bad memories, or maybe they're not willing to admit, oh yeah, I was a drug user when I was younger, and maybe that would contribute. And so another example that I like to use in class, if I were doing a study on diet and I asked you what you ate for breakfast last Thursday, let's say, a lot of people, unless you eat the same thing for breakfast every day, you're not going to remember what you ate. Or if you do remember, you'll probably leave out that you had a candy bar for breakfast or whatever. And so one of the problems with case control studies is you either have a bad memory or you may minimize your truthful responses. And so that's another type of study. Another study is what we call a cohort study. And that's where you're going to follow a group over time. Some of these studies can last decades, and they are prospective, which means you look forward in time. The most common example, there's a Framingham physician study named for Framingham, Massachusetts. One of my professors at the University of Utah was in this study. He was enrolled as a medical student, and then they followed him for 4 decades. And since it is prospective, it's nice because you don't have to worry about memory problems. You can track people in real time. You can see what their diet is, whether they're smokers. And in fact, one of the interesting things that they did in his study was they would send them pills in the mail, and they would say, here, take this. You don't know if it's a placebo or if it's a drug. One of the things that they wanted to study was if aspirin helps prevent heart attacks. And so they would send half of the subjects aspirin, they would send half of the subjects a placebo pill, and then they wanted to compare heart attacks over time. And they did find, in this case, that the people who took the aspirin every day had fewer heart attacks. And so that was one of the things that they found there. So let's see. So some people are biased against observational studies because they think, basically because they think that they are more subject to confounding and lurking variables. But sometimes it's the only ethical way to study certain things. I can't force people to smoke. I can't force people to take birth control. Or whatever. And so a lot of times that's the only way you can get data is to do some sort of an observational study. Okay, so does anybody have any questions on observational study types? I feel like I need a drink of water. I wasn't planning to talk all this long today. All right, so I'll take that as a no, or you're all on mute and I didn't hear you. So please interrupt me if you have any questions. All right, so let's talk about experimental design, okay? Now, the idea with experimental design is we're gonna have a control group, and the idea is the control group serves as a baseline treatment that can be used to compare other treatments. So blinding is a term that we use that refers to non-disclosure of a treatment that a person, sometimes we call that an experimental unit because it doesn't have to be a person, is receiving. There are 2 types of blinding. There are single blind and double blind. So usually in a single blind experiment, the subject does not know if they are receiving a drug or a placebo. And in a double-blind study, both the patient and the doctor don't know if they are receiving treatment. So the reason why is sometimes a doctor may bias the results One of the greatest examples is there was a Canadian study done on prostate cancer, and it was a single blind experiment. Basically, what the doctor did was he wanted to determine if drugs or surgery were a better treatment for prostate cancer. One of the biases that the doctor brought into the study was if a person was young, then relatively young, they were more likely to get the surgery because he felt like they would handle the surgery better than an older patient who would have more complications. So it turned out that one of the biases was the study was the subject's age. And so because the doctor, it was a single blind experiment, he didn't randomize whether people got the drug or people got the surgery. And so it biased his results, and it looked like surgery would perform much better than the drugs. And so what he had introduced, unintentionally probably, was the lurking variable ended up being age, because he couldn't determine whether it was age that affected the study versus the drug. And so so that's an example of why double blind is better. So I just heard a beep. Is somebody, I don't know, maybe somebody came later. I don't know what happened there. Or does somebody have any questions or anything? Okay, I guess I just heard a beep. All right. So as part of your, this is kind of a bummer that I've got the answers in my notes here, but so this is an example of something that might be a homework problem. So there was a placebo-controlled double-blind study. I wanted to see if Lipitor prevented cardiovascular disease. 2,838 subjects participated. They were aged 40 to 75. They had type 2 diabetes, no prior history of cardiovascular disease. The subjects either took 10 milligrams of Lipitor daily, of which there were 1,479 subjects, or placebo. There were 1,411 subjects that took the placebo. You can see those are close together. Sometimes people drop out of the study. So the response variable was a cardio event. So the population was people that were aged 40 to 75 with type 2 diabetes that had no prior history of cardiovascular disease. The sample was your 2,838 subjects. Why are these different? A lot of students like to know that. Ideally, you want those the same, but people often drop out if they don't think the drug is helping, and it's just something that we have to deal with. So a lot of times, the placebo group is smaller than the daily group just because people drop out of the study. And as we learned yesterday in class, you know, the IRB says a person can drop out of the study for any reason. And so you will notice that the placebo groups are usually a little bit smaller. These are pretty close, so that probably wouldn't matter too much. Okay. So, all right, we'll move on to the next thing. Any questions about that? Do you guys feel pretty comfortable identifying the population and the sample in something like this?
When they performed that study, did they take into account any type of medications that the type 2 diabetes patients would have been taking? And I mean, as far as like any type of side effects or combined effects, as far as.
So that can be really tricky. Based on what is written here, we don't know. You know, you can only go with what's written here when you're doing these things. But yeah, you're kind of highlighting the issue with lurking variables, such as other medications, and confounding. Will other medications affect the Lipitor? Yeah, certainly that's possible. We don't, based on what's written here, we don't know. So that's the case with every study. There are always lurking variables that could impact a study, and so it's just something you kind of have to deal with, and hopefully you've done a good job with that. But to be honest, you never know.
Gotcha.
Okay. All right, let's talk about the steps to designing an experiment. The first thing you need to do is you need to identify the problem, and you need to be explicit. You don't want to say something like, we want to say if there's improvement between this group and this group, because that's just too vague. How do you know if an improvement is made? So this happens all the time. I remember when I was a student researcher at the University of Utah, I had a doctor, and she wanted to see, and this was almost the exact term she used. She was studying skin cancer, and she wanted to see if there was improvement with people's habits with regards to skin cancer. So I said, my first question was, how do you measure that? And then she was like, oh, that's a good question. Because you've got to be very explicit. So how would you measure if somebody improved their habits? Would you follow them around and say, oh, they're wearing a long sleeve shirt and they're wearing a hat? Is that improvement? Maybe. Are they wearing sunscreen if they go outside? How do you measure how much sunscreen they're using? I mean, you'd have to really get specific. In her case, she just wanted to see, she decided that she was just going to teach a class, and then she was going to give a pre-test and a post-test and see if people change their answers. Once again, you have to say, okay, so you just had a class. Are people going to say, oh yes, I'm going to change my answer because I just had this class and I learned this thing? But then they don't actually put sunscreen on, they don't put a hat on, they don't wear long sleeves when they're outside. So anyway, those can be all questions as to whether something really is helpful or not. So determine the factors or the variables that affect the response variable. Two things that you should almost always include in every study are age and sex, among other variables. That, if you're measuring plant growth, let's say, some things that might affect plant growth are sunlight, water, the type of soil that they're in, the amount of fertilizer. And so the idea here is maybe you'll want to control the sunlight. You'll put the plants in a greenhouse, for example, and they'll all be in the same soil, and they'll all have the same amount of water. Maybe the only thing you'll change is the amount of fertilizer they get, so that you can decide if one fertilizer works better than another fertilizer. Determine the sample size that you need. We'll talk about sample size calculations later. You want to control the level of each factor, and you'll also want to randomize. Make sure that you're properly, if we go to that, back to the example, maybe you're going to control the sunlight, the water, and maybe you'll control how much fertilizer the plant gets. And then you need to make sure that you're randomizing your plants so that they so that you make sure you don't have any. The idea, let me back up a second here. The reason why we like to do randomization is because hopefully It helps cut down on lurking variables and confounding in an experiment. And so if it's random, then they will cut down on that. And so that's why we like to randomize. Step number 5, we're going to conduct the experiment and we will assign to treatment groups. And then so we'll collect and process our data. And then step number 6, we will test the claim. The 2 main ways that we will test the claim are to find confidence intervals and to do hypothesis tests. So I will just warn you that when we get to, when we start talking about hypothesis tests and confidence intervals, that's when this class will get really hard. Especially the hypothesis test. I know that's where, when I was a student, that's what I struggled with most. Anyway. Okay, so we're still talking about experiments. A completely randomized design is when we randomly assign a treatment. So I've got this this example here. Farmer wants to identify the optimal level of fertilizer for growing soybeans. And so the response variable will be the number of beans that he gets out of the crop. So you'll randomly assign the, so this is a kind of a nice little chart that you should do. You'll randomly assign the plants to 3 groups. So maybe you'll have 20 plants in group 1, 20 plants in group 2, 20 plants in group 3. Treatment A will get no fertilizer. Treatment B will be 2 teaspoons of fertilizer. Treatment C will be 4 teaspoons of fertilizer. And then you will compare the yield and see which one is the best. So some factors that you should consider besides fertilizer are precipitation, sunlight, method of tilling the soil, plant type, and temperature. Sometimes you can control that if you put it in a greenhouse. But if you're doing it outside, you know, sometimes a greenhouse isn't ideal, and you know, maybe you'll be able to control, or maybe you want to put those in a field. So we've got 60 soybean plants that are our experimental units. The fertilizer will have different levels of fertilizer, nothing versus 2 versus 4. So as I mentioned earlier, the different things that could affect plant yield are precipitation, sunlight, method of tilling, the type of the soil. There could be variations from plant to plant, and so that's why we're going to randomize, and of course temperature. So this is uncontrollable, but especially if it's outside. If it's inside, you can maybe control that, but it will be at least the same for every plant. You can read through this. I think I'm kind of repeating myself. Okay, so does anybody have any questions on completely randomized design? Okay, I know I'm throwing a lot of terms at you. All right, let's go to a matched pairs design. So this is another kind of experiment. This is where the experimental units are paired up. The pairs are selected so that they're related some way. So one way you could do an experimental or a matched pairs design is you're going to test the same person twice. You'll test them before the treatment and after the treatment. So the one person is his own pair. That can be a useful thing. Twin studies are very popular. A husband and wife, those are natural pairs that you could do. You could pair people based upon geographical location and so forth. So in a matched pairs design, one individual will receive one treatment and then the other receives a different treatment. And then the matched pair is randomly assigned to the treatment group. You could do a coin flip or some sort of a random number generator to separate the treatments. And so then you're going to look at the difference for each matched pair. So one common matched pairs design is kind of the before and after treatment. The nice thing about that, especially with an experiment, is it's the same person before and after. Also, like with acne studies, I know they will do this. Maybe they will take a person's face, they will split it down the middle, and they will treat their acne on the left side with treatment A and on the right side with treatment B. One of the nice things is, in that case, the person has their own same genetics, and then you can compare treatment A versus treatment B. So a lot of times the person can be their own matched pair. And so these are some, before pre-test, post-test, or before and after kind of experiments. So an example of this would be an educational psychologist wants to determine whether music has an effect on students' ability to learn. They'll design an experiment to help answer the question. So one way to do this would be with a matched pairs design, where you don't necessarily match with the same student, but maybe you'll match students according to IQ and gender. And so maybe you'll match students based on their IQ and gender. So you'll have a woman with an IQ of 110 and another woman with an IQ of 10. And then maybe you'll change the, use a coin flip to see which one gets the quiet room for the test and which one has music playing in the background. Each student will be given the text and asked to study. And then after 2 hours, the students will enter a testing center and take a short quiz. And you're going to compute the difference on the scores of each matched pair. And any difference will be attributed to the treatment. So rather than have this design up here where you're randomly doing this, an example of a matched pairs design would be this diagram right here. You'll match according to gender and IQ. You'll randomly assign a student to each pair and treatment. You'll administer the treatment in a matched pair, and then you will compute the difference. Okay. So I know we're getting short on time here. One note is it's often the case that the experimental use are not randomly selected for the study. And this is often because you need to have them match a common trait, such as blood pressure or IQ or whatever the reason. So the participants are recruited to volunteer. Once we have your experimental units, we'll use random sampling and assign them to treatment groups. So there is some randomization involved. And we assume that the students are random at the start of the experiment and the treatment is the only difference. And so therefore we can say that it was the treatment that caused the difference. So any questions there? I feel like I'm doing a lot of talking. All right.
I have a question about the homework.
Okay.
Now we're gonna do 8, 9, and 10 homework by Monday.
Yeah.
Okay.
We're basically done with this. Randomized block design is going to be similar to a randomized design, but the difference is you're going to a block on a certain variable and then you'll randomize. So I'll let you read about that in the book. But let me just remind everybody. Let me go back to here. So I will have homework 8, 9, and 10. Those will be due all on Monday. We'll have a quiz on all 3. Maybe I should delete all this stuff. I copied these from my previous semester. That's why the dates are all messed up, but I'm probably just going to have to delete them. Just as a reminder, your homework, hopefully this loads chapter 10 in a new window. Yeah, so here's your chapter 10 homework. So I'll have chapters 8 and 9 that will also be due on Monday as well. I think most everybody, do you have any other questions about the homework? Or anything with the class?
Yes. Could you remind me right now? It shows that chapter 10 is due in 4 days. Like, is it due the next day, the next class day?
Yeah. So typically the homework will be due the next class day. So now that we're a Monday, Wednesday, Friday class, I guess you're going to have 2 days to do the homework. I thought this was a Monday through Thursday class. I apologize. But I guess this gives you an extra day. So you have 3 days to do 3 chapters. And also yesterday, we didn't have the Macmillan learning in my Canvas course. So I apologize for that. But they set it up without that. So any other questions?
The quizzes are also due before the class, right?
Correct.
Okay.
And so the quizzes should be fairly short, usually about 5 questions. So I usually put a time limit of about 30 minutes on there. Okay. And I will reveal the answers 5 minutes before class. So you can kind of look and see what you miss, and then you can ask me questions. I usually don't record quiz question, or you can ask me questions, but I usually don't record those, so I won't post those. But all the lectures will be recorded otherwise. So, any other questions you guys have?
Sorry, just one more. Looking at how much a homework is valued at, it's 100 points, correct?
Yeah, remember, so let me mention that really quickly. So, so your homework is only 10% of your grade. So just keep that in mind. Your quizzes. So here's the weird thing about quizzes. I want to put the quizzes in here. Quizzes technically, I wanted to put this in here to give you an idea. It's actually going to be worth 0% of your grade because your quizzes will replace your lowest test score, and so your exams are going to be worth 60%. So this is where that is. So you may notice that it looks like your grades are going to change a lot based on homework and attendance, but once we start getting exams in here, then you'll see that it's not going to matter as much. So, and then of course your final exam is 25% of your grade, and then your attendance is going to be 5%. So I know that at the beginning of the semester, it looks like your grade fluctuates wildly, and it does. But it'll calm down once we get going in the semester, and 60% of your grade is going to be your exam. So that's really where I want you guys to do well. So, any other questions you guys have? All righty then. Well, I apologize for meeting on a day we're not supposed to meet. Thank you, Janie, for correcting the error of my ways. I'm used to, usually they do Monday through Thursday, and I just don't know why they did that this semester with the summer classes, because it's always been Monday through Thursday, so I don't know why the college did that. And I apologize for not noticing that. So. All right, well, I'm going to go ahead and stop the recording, and I will let you guys go. If you want to stick around and ask me any questions, then that's fine as well. So